Welcome back, Math 098. We're going to start with Chapter 7, Section 1, all about radicals and radical functions. So in case you're curious, radicals are basically those square roots. So the whole premise of this is understanding that square roots are undoing perfect squares, which is why I'm starting with that. Now, my encouragement for people is to make sure that you understand first of all, why do we call them square numbers? Like 1 squared, and 2 squared, and 3 squared. And the best way to explain this is just understanding that a perfect square is multiplying by itself. So 1 times 1. And you might be saying, well, why is that the case? So this answer is 1. Is because in a square that has side lengths of 1 and 1, to find the area, you multiply 1 times 1. So if you were to look at maybe I'll draw this out as if it's a 2 by 2 square, so you can actually see that there's 4 tiny squares in here. And the reason why there's 4 tiny squares in here is this side length's 2 and this side length is 2, so to find the area is 2 times 2. I can do the same thing with 3. Picture's going to be a little busy. That's okay. So when you have a square of 3 by 3, there's 9 tiny little squares in there. So 9 is a perfect square. So the whole reason I'm going through this is to get you to try and memorize. I strongly encourage students to memorize the perfect squares. 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. Because the more you memorize, the faster you can get to it. 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196. Look at the similarities there, pretty easy to remember. And then 15 squared is 225, and then I typically stop right there. My geometry teacher made me memorize the first 25 perfect squares, and it didn't stick. And I'm a math teacher, so I'd have to do some thinking to figure out what 16 squared is. So the whole premise then is if I were to ask you for the square root of, let's say, 9, I'm basically asking you what number times itself would give you 9, which is 3, which is, I think, very helpful to have these memorized then. So instead of thinking about what number times itself gives me 49, because I haven't memorized as the 7th perfect square, that this answer would be 7. That was a terrible look at 7, but you can forgive me there. And then a few other pieces is understanding that this is the same thing as the square root of 0 divided by the square root of 1, which the square root of 0 I didn't write up here is just 0. Square root of 1 is 1. Anyway, 0 divided by anything, any positive number would give you 0, or any negative number for that matter. Yeah. And then this one, square root of 16 is 4. The square root of 81 is 9. And then, we can stop right there. So just like before, you square root each piece. And by the way, you're allowed to use a calculator. You never have to just know how to do this. So if you want to try it on your own and then check your answer with a calculator, you have my permission. For instance, this last answer is 0.8. And if anybody wants to, I can show you with a calculator. At least with my calculator, all you have to do is hit second, the square button. You can just type it in there, 0.64, and you do get the correct answer. And you can double check that that's correct, because you can type into the calculator 0.8 squared gives you that square root number, 0.64. I want to extend this a little bit further and explain these answers a little bit differently. So let me change colors, because what you could do is factor tree down and see that 7 times 7 would give you 49. And because if we're looking for pairs of numbers that multiply to give you 49, it makes perfect sense that this answer would be 7. So if I were to rewrite z to the 8th power the same way, that means that there are 8 z's. I should have given myself more room, but I hope you can forgive me. And we're looking for pairs of numbers that multiply to give me that. So we have 1, 2, 3, 4 pairs of z's that will give me that answer. So this answer, the square root of z to the 8th, is equal to z to the 4th. Because there were 4 pairs, just like up here there's 1 pair of 7s that gave me 49. You can think of it that way as well. If you don't like that explanation, I like explaining it that way, that's just me. You could think of it this way, is the square root of z squared is equal to z, right? Because the square root and the square undo each other. So put that in the back of your mind. So really what's happening is we have the square root of z squared times z squared times z squared times z squared. Now the square root could go over everything, or just like up here, you can do each piece individually. So the square root times the square root times the square root times the square root. And as I mentioned before, each one of these square roots cancels out with the square, so we're left with z to the 4th. And there is one other way of thinking of this, and I don't know if I really want to explain it yet because it's on the next, here it is. Nope, that's not what I'm looking for. Maybe it's in Unit 2. Yep, it's in Section 2. That the index here, which is implied to be 2, you could rewrite it as a to the nth power divided by the index. So if you think of it that way, which I know I'm jumping ahead to Section 2, and going back, I'm not trying to confuse you, but I can see why that might be confusing, is because the implied index right here is 2, then the answer is going to be 8 divided by 2 as your exponent. Yeah, let's keep moving forward, and feel free to bring any questions to class if you have any. So in the same manner, we can rewrite this as the square root of 16 times the square root of b to the 6, which I hope all of you would look at the square root of 16 and say, okay, my answer is 4 from that. And if you like my way of explaining it, of rewriting b to the 6 as b times b times b times b times b times b, and look for pairs, well, you have 3 pairs, so it's b to the 3rd power. And again, you can do the problem like I mentioned here, where the implied index is 2, because it's a square root, and do 6 divided by 2 to give you 3 right there. It doesn't look like a 3. Whatever. Now there's a big difference between the last 2 problems, so stick with me. By the way, so far we've been just doing what's called the principal square root, where you just write down the positive answer. You notice all my answers have been positive. So the principal square root of 36 is 6, and then that negative is right there. So this is your answer. But what if you sneak that negative inside the parentheses? Now remember, the whole premise of this is a number multiplied by itself to the 2nd power needs to give me negative 36. So what number times itself would give me a negative ever? Never. There's no such number that when you multiply by itself will give you a negative answer. And the reason for that is if you're saying, why don't you just have it as negative 6? My response to you, well, negative 6 times negative 6 is positive 36. So there's a flaw right there. And we will fix this later. And you probably remember imaginary numbers from Algebra 2. But we're not concerned with that yet. That is a future Math 098 problem. Okay, so memorizing perfect squares will help you approximate radicals down the road. And that's another reason why I encourage students to know how to do this, to have the perfect squares memorized. Because as I look at that, I know that that square root of 45 is bigger than the square root of 6. But it's also smaller than the square root of 49. So since I know the square root of 36 is equal to 6, and I know the square root of 49 is equal to 7, and 45 is somewhere between those two, then the square root of 45 must be between 6 and 7. There we go. Now, if any of you are sitting there with a calculator, you can type it in. If you typed in the square root of 45, you would see pretty clearly that 6.708. I like to round to 3 decimals. So my answer is still correct. Bigger than 6, but smaller than 7. 6.708. All right. And I also want to share with you the cube roots. But now we can actually cube root a negative. And this first answer is -1. And my best way of explaining this is if you factor tree, which it doesn't really make any sense to factor tree -1, you can get a negative number to the third power will give you a negative answer. But the reason why I'm showing you this is basically the cube root, the index right there is 3, is asking you want groups of 3 now that give you that. So if you were to try and break down 27 as 3 and 9, and then you break down 9 again as 3 and 3, see how I'm looking for a group of 3 numbers that are the same? So the cube root of 27 is 3. And just like before, if I asked you to cube root a quotient, you can just cube root each piece. Cube root of 27 over the cube root of 64. Now we just did the cube root of 27. That was 3. And if you were to try to break down 64, here's the other way of thinking of this, is even if you broke it down too much, like 2 and 32, what do we got? 2 and 16, 8 and 2, and there's 3 2s, I'm making 8, okay, so there's 3 2s, and here's 3 2s. Well, instead of writing out the 2s individually, you can write them, well, I guess you could write them individually, like 1, 2, and then this one groups together to be 1, 2. So 2 times 2 would give you 4. Otherwise, some of you might be sitting there and saying, that's a lot of work. Why don't I just think of, well, it's got to be bigger than 3. This is cube root of 27 is 3. So how about I try 4 next? And you'd be right. 4 times 4 times 4 is 64. I did want to show you the calculator, though, because it's under the Math tool. It's the 4th option down. And by the way, you could do the 4th root. You just have to go to the 5th option and hit the number that you want. But we just want the cube root. And under alpha y equals, I can make a fraction and actually type in 27 over 64, and it spits out the correct answer, 3/4. So just giving you a heads up that you can use a calculator moving forward on that. But this is even more reason why I like explaining the groups of 3, because if you wrote out all 12 of those x's and you found groups of 3, 1, 2, 3, there are 4 groups of 3 to say that this answer should be x to the 4th. But my statement still holds from before, that you can look at your index and do the exponent divided by the index. 12 divided by 3 is 4 to get that answer. Now, I'm kind of running low on time. I want to finish this. But if you were to try to break down 8 as 2 and 4, break down 4 as 2 and 2, you can see that there's a group of 3 there. There's also 3 x's for a group of 3. And like I said earlier, you can cube root negatives that have an odd index, just not an even index. So this final answer is -2x. And I'm about at the end of my time, so I'll see you in the next video to do 4th roots, 5th roots, etc., etc.